so let's continue. This is going to be project number 2 for our Excel programming, macro programming. So our topic would be isotherms, isobars, and isocores. Actually, we're only going to talk about isotherms. The project you're going to work on would be, you'll talk about isobars and isocores. So for this project, you'll be able to create a macro that will generate a chart for using a for, next, or do loop, or while, when construct. And you can use the timer function and the loop constructs to animate a chart. Okay, so this is what we're going to do. We're going to create a spreadsheet that plots an ideal gas pressure versus volume isotherm at 1000 K. We're going to do it from 0.1 to 1 atmosphere in steps of 0.1 atmosphere. So your y-axis is going to be pressure. Okay, what would the isotherm look like? You have pressure versus volume, and it would look something like that, right? At a given temperature, pressure versus volume would look like that. And then you're going to create that chart, and then we're going to set the range of that chart from 0 to 1 atmosphere here, and then this is going to be 0 to 1,000 milliliters liters on the x-axis. And then what we're going to do, we're going to fix those axes. Okay, and then we're going to delete the data that we used to create the chart, so we'll have a blank chart. So after you have your blank chart, we're going to create a macro to regenerate or recalculate those data, but we're going to calculate them 1 second apart. So we're going to calculate 1 point, wait a second, calculate another point, and as we're calculating the data points, we're going to update our graph. So our graph is going to show what will happen to the volume of your gas as the pressure increases at constant temperature. And then we're going to revise our macro. This time we're going to instantly generate the isotherm at 1000 Kelvin, and then we're going to lower our temperature 10 degrees at a time, so 1000, 990, 980, and so on, and we'll see what happens to the isotherm. Okay, so that's what we're going to be doing. And so let me go ahead and pull up an Excel sheet. I'm not recording it. I am recording it. Okay. That would have been a lot of things to repeat.
Yeah.
Okay. So what I'm going to do here is I'm going to put here on cell A3 the temperature in Kelvin. Okay, so we're going to do 1000 Kelvin, right? Oops. And we're going to create a table of pressure and volume. Right? And what did we want our pressure range to be? We're going to go from 0.1 to 1 in steps of 0.1, right? So 0.1 is the first pressure. This is going to be in atmosphere. And then the next one's going to be 0.2. And then we're going to fill this row column to 1, so I'm going to do this right there. So from 0.1 to 1 atmosphere. And we're going to calculate our volume. What is the molar volume? This is going to be molar volume actually, okay? So we're just going to do 1 mole of gas. So how do you calculate the volume of a gas, ideal gas? What's the equation? PV, oops, PV equals nRT, so molar volume is V over N, right, is equal to RT over P. Okay, so we're going to put RT over P in our formula here. So what I'm going to do is I'm going to type equals R. What's the value of R? 0.08206 liter atmosphere per mole Kelvin times the temperature is B3. Cell B3 divided by the pressure, which is cell A6. Okay? So you're still with me? Now, I'm going to copy this down to the rest of the column, but before I copy it, remember, I want my A6 to change to A7 when I get to the next row, right? And what I wanted to change to A8 when I got to the row below that. But my B3, I want to keep it B3 regardless of where I put this formula. So what I do is, if I don't want the cell address in the formula to change, what do? I put a dollar sign in front of the letter and the number. So $B, $3, so that when I copy it, it will not change. So now I can just copy that down. And here it is. So you can see this is R times B3, which is a temperature divided by pressure. This one is R times B3 over A8, and so on. Okay? So this is my volume in liters. And I'm going to create a chart of pressure versus volume. It's actually molar volume, right? Liters per mole. So I'm going to insert a chart. Scatter plot. Right there. Let me make that smaller. Right there. Okay, and that's not what I want to graph. I want my pressure on the vertical axis and my volume on the x-axis. And I don't want these legends, so I'm just going to get rid of those legends and titles. And then what I'm going to do is, I go to Design, Select Data. I need to edit the data that Excel thought I wanted to graph, so I'm going to edit. And I want my x values to be the volume and my y values to be pressure. Okay? And so now I have that. So I have pressure on the vertical axis, volume in liters on the horizontal axis. And then what I'm going to do is I'm going to draw a smooth curve through it. You know that P is inversely proportional to volume, so you can use a power trend line. The power would be -1. Okay, so you do add a trend line, you just do a power. Okay, and trend line, and you can see it just draws a nice hyperbola right there. So that's your pressure versus volume isotherm. Okay, now we're gonna set our axes so that when we're changing the data, the axes don't change. So we're gonna fix our axis. So I'm gonna right click on vertical axis, format the axis. I'm gonna fix my maximum to 1 and fix my minimum to 0, just so it doesn't get changed when I change my data. Because if you want to see the animation on a given chart, you want that scale to remain the same. And then for my horizontal axis, I right click, format axis. I want to fix my maximum to 1000 and my minimum to 0, so that that scale will not change as I'm doing my animation. Okay, so I'm going to go ahead and pause to give you a chance to get caught. Okay, so that's our isotherm at 1000 Kelvin. Let's see what happens to our isotherm at 300 Kelvin. That's our isotherm at 300 Kelvin. At 500 Kelvin, that's what it is. At 1000 Kelvin, that's what it is. Okay? So what we're going to do now is we're trying to animate this so that it will graph the data 1 point at a time, and there's going to be a gap of like 1 second between each point when it's graphing it. So I'm going to get rid of this data now. Okay. And now I'm going to go to my macro. I'm going to record a new macro. So record macro. And again, my favorite letter is M. Control M will activate this macro. Okay. And we're going to stop recording the macro. And now I can edit that macro. It's a do nothing macro right now. Okay. So what am I going to do? I'm going to read my temperature, and my temperature is in what? T is in cell, so I type cells. What row is it? Row 3, column 2, right? It's cell B3. So row 3, column 2. And just to make sure that that is in fact my temperature, I'm just going to do a message box just to verify. Message box temperature is empty. Okay. And I go back, and then I'm going to press Control M, and its temperature is 1000. So I'm okay. I read it correctly. Okay. Let's continue editing the macro. I'm just going to get rid of that message box. I know it's correct now. And then I'm going to calculate from p equals 0.1 to 1 in steps of 0.1. One way you can do that is using what's called a for loop. So first you define the minimum value for p. So let's call that p underscore min. What's our minimum p value? 0.1, right? And if you look at, you're going to go from 0.1 all the way to, let's see, 0.1, oh, I'm sorry. You're going to go from 0.1, 0.2, all the way to 1, remember? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 data points, right? So, what I can do is I can go back here. I can say for I equals 1 to 10, and then I say next. What this does is the program goes through a cycle as a loop. It starts off by assigning a value of 1 to I. It goes to another cycle. It assigns a value of 2 to I, and so on. And I'm going to say that the pressure would be equal to whatever the minimum pressure was plus I minus 1 times 0.1. Okay? So what's going to happen the first time it goes through? It's going to say, the first time it goes through the loop, it says I equals 1. What's 1 minus 1? It's going to be 0. So my pressure is whatever P min is. It's going to be 0.1. Okay? And then the next time it goes through the loop, this for loop, it's going to set I equals 2. And then so 2 minus 1 times 0.1 is 0.1. P min is going to be P is going to be P min plus 0.2. And then the next time it goes through, it's going to be P min plus 0.3, and so on. Okay? So let's verify that that in fact works. I'm going to go ahead and get rid of this. And so I'm going to say Control M. What happened? Oh, I haven't recorded it on the correct cell. So it's gonna be cells. What's the first row? Row 6, right? So it's gonna be then row 6. So for I equals 1, to get to 6, how do I get? What do I add to I to make it 6? What do I add to 1 to make it 6? 5. So our cells I 5 plus I, and that's the row, and column 1, okay, is equal to P. Right? So the next time it goes through this loop, it's going to say cells 5 plus 2, 5 plus 3, 5 plus 4. So it's going to increase the row location of the cell that you're going to put your value of P in. Okay, so let's do this. Hit Control M, and you can see it works. Okay, try it again. Go back. Okay, so 5 plus I, 6 plus 5 plus 1, 5 plus 2, 5 plus 3, all the way to 5 plus 10. Okay, so that's how it calculates the value of P. Okay, let me pause this see if you're all caught. All right, so let's continue. We're now gonna calculate the volume. What would be the volume? Volume is V equals R which is 0.08206 times the temperature, which is T, right, over P. So that's your molar volume. Okay, and we're going to put those where? Cells 5 plus I, same row, but in column 2, right? So we're going to put your volumes in the same row, but column 2. So now I go back, I can hit Control M, I can see, you can see that it generates your data right there, as expected. Okay? Pause and get you caught up. Alright, so what are we going to do now? This time around, we're going to let this do graphing happen so that it pauses 1 second in between points, right? So I'm going to get rid of these again. And I'm going to go back to the code. And I'm going to say, I'm going to do this. I'm going to say timer start equals timer. Okay? And then what it does, what I'm doing is I'm storing the value of the time in this variable called timer start. Okay? And so timer is just going to keep advancing as time advances. So, but the value of time at the beginning of the iteration here, at the beginning of the loop, is timer start. So what I'm going to do is, if the timer now, okay, I'm going to say do loop until timer minus timer start is greater than 1. Okay? That means the difference between the start time and the current time is greater than 1 second. If it's less than equal to 1 second, just keep looping through this. So this is like an infinite loop. If this condition down here is not satisfied, this loop will just go on indefinitely. But of course, after 1 second has passed, this condition down here is going to become true, and then so it will stop doing this loop. Okay? So let's do that. I'm going to press Control M now, and see it's doing it 1 second at a time. Okay, spacing it out 1 second at a time. But it's not updating the graph, right? This is a bug in Excel. So you have to manually force Excel to update graphs. It doesn't update graphs for some reason, and there's been a lot of discussion of this in forums on the internet. So what you can do is, okay, you force Excel to recalculate the graph after each point. So what you do is you can say, okay, after it's done, okay, after it's calculated pressure and volume, you force Excel to recalculate the spreadsheet. So just type the word calculate. Okay, it's called a method for the application, the calculate method. And so let's go ahead and try that now. You may have gotten into an infinite loop if you haven't typed it right. Okay, escape will get you out of it. Okay, so now let me show you how this works now. You can see what happens. As the pressure increases, your volume decreases. And so you're showing that animation of what happens to the volume as the pressure increases at constant temperature.
What if like the first 5 one by one, and then it like stops and loaded all the other ones together?
It's pausing.
Yeah, it's pausing like this.
I'm probably like 2 and 11 and then just...
Now another way you could have done this waiting here for 1 second is, instead of loop until, do loop until, you can do another alternative way of doing this is to say while timer minus timer start is less than 1, then you do a bunch of stuff, but you can just say do nothing, and that's the end of the while. So that loops around this will keep looping until timer minus timer start is greater than 1. So same thing, it works the same way. So you get the while loop allows you to test for the condition before you go into the loop. The do loop construct allows you to test the condition at the end of the loop, whether you can exit the loop or not. Okay, so if I did this, I should get the same result. Okay. And there's that not responding thing. I don't know why Excel's doing that. It must have gotten busy doing something. So, all right. But anyway, that's how that works. Okay. So that's your loop. Now, the next thing we're gonna do is we're gonna animate how this entire curve changes as temperature changes, right? So we're gonna put this inside a bigger loop, a bigger for loop. You can say for t equals, let's say 1,000, going down to 300 in steps of -10. Okay. And I have another next statement here. So what I've done is I created this for loop inside a bigger loop, and every time it goes to this bigger for loop, it changes the temperature, starting from 1,000 to 300. Now I don't want to do it step by step inside, so this thing right here, I'm going to take it out. Okay? I'm just going to take that timer, so I'm just going to let it go as fast as it can. Okay, so it's gonna start with t at 1,000, and then it's gonna step down 10k until it reaches 300. Okay, so the -10 means step down. So let me see how that works. I press Control M. Oh, it just did the last one, so I have to do one more correction here.
If you watch your data, it freaks the living crap out.
Yeah. So what I'm gonna do is after it completes one isotherm, I'm gonna let it update the graph. So I'm gonna say after each of these isotherms, go ahead and recalculate the entire spreadsheet, so it will update the graph. Okay. So now I'm gonna say, okay, get rid of it. Press Control M. It's a lot smoother. Okay, it's updating the graph after it recalculates your data set. And if you want to give it allow some time in between temperature steps, you can do that. If you want, you can say, what was that? You can put a loop here. You can say actually, we can put this timer out here. So now you can say do loop until timer minus timer start is greater than 1. Okay. Let me save that. Oops. Let's go back here. This is going to be a slow one. It's going to do it every second. Okay. So what's happening to your isotherm as the temperature decreases? It's shrinking, right? The volume is shrinking as the temperature decreases at constant pressure. So you can see your isotherm going a little bit more slowly. Alright, so that's that. Now it's your turn. You need to create a similar spreadsheet. Okay. And so there's again 6 different things you can do here. So there's 6 of you, 1 for each. Okay, so Scott, do the first one. Brittany, do the second one. Shadra, do the third one. Lauren, the fourth. Um, Matt, do the fifth one. And Drew, you do the last one. Okay?